All right, good afternoon and welcome to today's session. I probably need to press just one.
Good. Press one. There you go.
Where we basically talk about best practice for deploying Oracle workloads on VMware HCI, hyperconverged infrastructure, vSAN offering. Right? So without other, standard disclaimer, you guys have seen this pretty much every day of the week, every hour of the day, so it's okay. I'm going to skip through this. This is the agenda for today's discussion, so it's kind of jam-packed, but I'm going to start with requirements for BCA. So when I say BCA, it means business critical applications, right? So the way you term business critical application is any application that puts food on the table, period. That could be your homegrown Java app, that could be your Oracle databases, SAP, SQL Server, your MI, your AL, HPC, and I don't know what else I'm missing here. But pretty much anything that's mission and business critical, it falls in the bucket here, right? So what are the requirements of the BCA workloads? How do we overcome them with our VMware HCI solution? I'll go a bit into the Oracle on vSAN solution history. I'll talk a bit of Oracle and extended Oracle RAC on vSAN. I want to talk a bit about workload performance characteristics on vSAN all flash. I'll talk a bit about day 2 operations as well. I'm going to then round it up with migrating the Oracle workloads from on-prem to the cloud. So you guys have heard of VMware Cloud on AWS, which was released last year. And a bit about database as a service, some best practices, conclude, I'm going to take questions after that. You were asking me about Oracle licensing, that's it? No questions on Oracle licensing. You want to talk to me after this? Come meet me, right? You got to give me a gift. You have to bring me a gift. Either a bottle of scotch or a beer, and then yes, I will sit and I'll talk about this. All right. Some of the key takeaways, I'm going to skip through this for essence of time, but requirements. See, any business critical application has a lot of requirements, right? You need to have the availability, the performance. You need to have scaling up, scaling out, scalability, the resiliency, the durability, right? Security, recoverability, and so many other abilities that are missing around here, right? And Oracle is no other different. Oh, sorry. Too fast. This is something I want you guys to have a look at. So typically what happens is, so I'm from the field as well. When I talk to customers, the first question comes out, oh, well, if I deploy Oracle databases on vSphere, or if it's vSAN, if it's VxRail, or even if it's VxRack, or for the matter, VMware Cloud on AWS, is the design methodology any different? And the answer is a big no, it's no different, right? These are the steps that you would take when you deploy any app, Oracle in this case is a use case, on a physical architecture. So this is no different than deploying Oracle databases on VMware. Some of the benefits of running databases on VMware, I spoke about performance, consolidation, provisioning, workload management. You also have BCDR, HA. So let's talk about those. See, there are some storage concerns when you talk about BCA, right? Using traditional storage. Some of them are scaling up, scaling out of storage, right? There could be complex storage management, or even, some inefficiencies like capability of non-disruptive operations. There's a high deployment cost anytime you set up any storage array. Even high operating cost as well, right? So we'll see how we are able to meet these challenges, right? And satisfy the BCA requirements using VMware HCI, vSAN. I'm going to hand this over to Chen to talk about that.
Hi, my name is Chen. I'm actually representing my coworker Plani to be here actually because we don't have enough budget for him to come over. But I'm going to talk about some Oracle benefits on vSAN. How many of you know vSAN? Okay, how many of you deployed vSAN before? Okay, only a few. Okay, I'll probably just spend some time on there. So with vSAN, we have the 6.7 just released last month. With that being said, we can just, with confidence, we can just deliver you the lower TCO, the simplify your maintenance operation, and give you the good performance and help you with from management perspective, from the operation perspective. Okay, so this is what vSAN does, and a lot of sessions talking about vSAN. I'm not going to just repeat that stuff here. So from the use case perspective, vSAN can do a lot of use cases, including the next gen BCA database, as well as VDI traditional stuff, and Robo. We can do containers, and we're doing a lot of, including like SAP HANA, which is what I'm doing right now. So this is what vSAN can do, and I believe Oracle must be the important part. And this is what vSAN looks like with 6.7. release or 67U1, release last month, vSAN can give you the capability like, okay, high performance. And what is vSAN? So for somebody who doesn't know vSAN here, I give you a brief introduction here. vSAN basically we're using the local storage within each of the single ESXi host and use the, the high-speed network to connect them together to carve out a single data store to contain your VM and VMDKs. And we're using storage-based management to give you like different capability. Either you want to go for performance or capacity or encryption, whatever you want. So we can just provide you data service based on your different requirement against each. It's actually on each single VMDK level. So for example, you can just do capacity for your for the data disk, and you do the performance for log disk, for example. So those are deliverables we actually starting from 2015, from the hybrid cluster to now we're doing the all-flash cluster. Recently we just released the database 12c on VMware's vSAN 6.7 with high performance version as well as with high performance hardware. I'm going to introduce those the test cases and the testing we've done and the results going to share with you guys. Okay. So what's the benefits, to deploy Oracle on vSAN? Basically, think of vSAN to the Oracle, just the data store, just the storage, right? So vSAN can have like different configuration, including hybrid, including all flash. It can just give you like different choices. Like if you need capacity, we can satisfy your request. If you need performance, you can just use all flash. So, for what really changes across different vSAN versions hardware, we just bring you different data services, right? Different for example, in 6.2 version, we just introduced the deduplication compression and erasure coding. 6.7, we got encryption very mature, and 6.7U1, we got the feature just developed. So with the vSAN developed so far, we can just introduce a lot of feature and with the benefits introduced into the Oracle world, right? So for example, how can we design Oracle? How can we use a RAG design based on different architecture like a stretch cluster or two-node cluster, or there's a regular cluster? vSAN just can give you different benefits you want. Okay, let me just hand this to Sudhir.
Sure. So this was the first solution that we released in 2015, as Chen mentioned. So this was an Oracle RAC 11204 on 6.1 hybrid. So basically it was a 4-node ESXi server, 2-socket, 20 cores each, half a terabyte of RAM. And and on top of that, we had a 4-node Oracle RAC. Every RAC node was 8 vCPUs, 64 gigs of memory, And each ESXi server had 2 disk groups. So basically, as Chen explained, right? Yeah, there are 2 disks or 2 types of disks in a disk group. One would be for cache and one is for capacity. So every disk group had the 800 gigabyte SSD for cache, 5 1.2 TB spinning Rust for capacity. The vSAN policy, this was set to default here, but this is something that we did. See, what happens is with Oracle RAC, when you go back to setting up Oracle RAC on vSphere, key thing is the VMDKs have to be shared. In order for the VMDKs to be shared, you need to use the multi-writer flag. In order to use the multi-writer flag, your VMDK has to be set to eager 0 thick. So it can't be lazy 0 thick. It has to be eager 0 thick, right? And the equivalent of setting up eager 0 thick is OSR equal 100%. And OSR stands for object space reservation. So by doing that, you're declaring your intent that each and every block in that VMDK will be eager 0, right? So that way, your multi-writer flag is on the VMDK, and hence you're able to use multiple virtual machines to share the VMDK. So on top of that, you're able to run your clustering software, right? So that was the Oracle RAC disk layout. The KB article that we followed for this thing was 212.1181. In case if you guys are interested, for vSphere, it's 10.34.165. Right. And again, I spoke about the multi-writer support enabled for the VMDKs for the Oracle RAC. It's the same. The steps are exactly the same, excepting for vSAN, you have to set up OSR equal to 100% of the storage policy, attach it to the VMDK when you provision it, make sure you set it to eager 0 thick, voila. Couple of test scenarios that we ran as part of this solution. The first one was we ran a TPCC-like workload, basically swing bench, to generate OLTP workload. That was a 100-user session, on this 4-node Oracle RAC cluster. SCAN stands for Single Client Access Network. Basically, think of it as a logical load balancer, right? So all user sessions connects to this Oracle logical load balancer, and once it does load balancing, it does failover, and it does a lot of other good things, right? So we use that. Couple of resiliency tests we performed. We said, hey, you know what? Why don't we just go and fail a single disk, and see how vSAN behaves? Well, when that was successful, we said, okay, how about a disk group failure? Let's fail the entire disk group and see what happens. Nothing really happened. Host failure. So vSAN was able to recover from all of these failures, right? So the resiliency and the durability factor of that was proved beyond any doubt. We also did the vMotion test, because the first thing that comes in an Oracle DBA's mind is Oracle RAC is so latency sensitive, right? Now, if I try to vMotion an Oracle RAC cluster, well, what's going to happen? I'm going to have cluster eviction. I'm going to have node eviction, right? I'm going to have all kinds of bad things are going to happen to me. So we tried even doing that, and guess what happened? Nothing happened. So the key to the whole thing is best practices. So when you set up even a single instance database or an Oracle RAC cluster on vSAN, or for the matter, vSphere or VxRack, VxRail, VMware Cloud on AWS, whatever, best practices are very critical. And I do have a slide that shows all of the best practices. All right, see what happens is, we having conquered the Oracle RAC within a data center, we said, you know what, can we stretch it? Can we stretch it across metro distances, right? Making sure that we have this 5 millisecond, the 5 millisecond round trip time latency that is required by Oracle RAC. In fact, it's not required, it's recommended to have 5 millisecond round trip latency time. Can we do that, right? So yes, we came up with this vSAN stretch cluster scenario. We had the external witness on site C. Keep in mind, site A, where you have 2 ESXi servers and 2 Oracle RAC nodes. Site B, where you have the ESXi server 3 and 4. The other 2 Oracle RAC nodes, they have a 5 millisecond round trip latency. Site A to C and B to C was less than 200 milliseconds, right? And that's where we had the external vSAN, external witness for the vSAN stretch clustering. That's for arbitration. So any external or any stretch cluster needs an arbiter in case you have issues, in case you have a split brain. Who wins? And then who takes a dive, right? So Oracle RAC has an algorithm called Stone It. Stone the other node in the head. That's pretty much what this is here. All right, putting it together. So you know what? We did Oracle RAC within a data center. Now we did extended Oracle RAC across metro distances. Great. That was HA. Now I need DR, right? And for DR, we use Oracle Data Guard. You don't have to use Oracle Data Guard. We just use Oracle Data Guard in the solution here just to show that you are able to provide HA and DR capabilities for any Oracle workloads running on vSAN. For backup and recovery, we use Oracle RMAN. That's typically what Oracle recommends, to use Oracle RMAN. We did the same as well. Everything is available here. So whatever I spoke about last 30 seconds or a minute and a half, so we have it here. We released it in December 2015. Sorry. Back to you.
All right, it's me again. I'm going to introduce how Oracle 12c workloads vSAN 6.7. This is an Oracle single instance. I'm just going to introduce, for example, different policy give you different capability on Oracle. So here, this is the configuration we have. If you're looking at ESXi configuration, we have 2 disk group per host configured, and each of these groups is using NVMe as a cache tier, and the SAS SSD as a capacity tier. So I would say it's kind of like a beefy hardware, and with the 6.7. So like I say, high performance version with high performance hardware. Let's see what number we can get from the slop testing perspective. And from Oracle VM configuration perspective, we have 12 vCPU and 128 GB memory configured, Oracle Linux 7.4 and 12c installed. And we got SGA 64 GB and PGA 32 GB configured. Okay. So I would like to emphasize some configuration perspective. For example, each Oracle VM, we will have 4 PV SCSI controller configured, because PV SCSI controller can give you more queue depth. And once you have a high performance VM, you need to have the PV SCSI controller configured. And for different purpose, we have like different VMDKs. For example, operating system, data, redo log, and FRA. So each of them should be assigned to a dedicated PV SCSI controller. Okay, so for those like data, we have 4 VMDK configured, or 8 VMDK configured. Redo, we have 2 VMDK configured. And all the configuration, you can just refer to the Oracle database on VMware best practice guide. Any questions here, by the way? No? Go. Okay, so this is how we configure testing. Like HCI2617BE, we have 1 or 2 Oracle single instance configured on the host, and we do the slop testing. So like a 70/30 read-write testing with 4K testing. So we have 32 schemas with of the 128 gigabyte each. The threads we set to 1, and I'm going to show you the results and number later. From the storage policy perspective, here's why I'm saying vSAN can bring the benefits to Oracle. So we can have like for different purpose, you can have different configuration. There's no best configuration or worst configuration. It's all about trade-off. You want a performance, and you probably lose some capacity. You want capacity, you may have some performance overhead, right? So the first configuration I mentioned here is R1. Basically, we have all the VMDKs configured using default storage policy, which is just two-way mirror and with checksum enabled, and which can bring you the high performance to all the disks, including operating system data as well as the redo logs. The second one I called R15. Basically, it's using R1, so two-way mirror still configured for a redo log. For all the other disks, we're using erasure coding for basically the RAID 5 configure to give you the capability of have more capacity configured, right? So give you the capacity benefits. And in this test, we did not turn on the deduplication and compression. Basically, I'm just going to compare the results between R1 and R15 in the next slides. Okay, so on the left-hand side, you can see here is a graph, and this is R1, R15. And if we just compare from the latency perspective, you can see from the read latency perspective, R15 definitely has a way higher latency, 3.8 millisecond versus 2 millisecond, right? And if you're looking at the write latency, it's the write latency, but if you're looking at the write performance, it's about like 26,000 IOPS versus like 20,000 IOPS. This is the overhead introduced by the RAID 5 or erasure coding. Like I said, erasure coding can bring you the capacity benefit. However, since it introduced the performance overhead here. So here, what I would like to say is like R1 can bring you high performance, and R5 can give you high the high capacity. So when you're deploying the Oracle on vSAN, you should know your purpose, what you want. You want high performance or high capacity. So it's based on your decision. So you can just configure based on your decision. Give you, Oracle vSAN just can give you like different options for different purpose. Okay, so still we have R1 and R15 from storage policy configuration perspective, but however, this time we enable the deduplication compression and we do another comparison here. And as you can see, we still have some latency and the IOPS difference between R1 and R15. So what we found out here is that IOPS reduced, however, consistent latency with and without deduplication compression. So no matter if dedupe compression turned on or turned off, we can always find out, okay, the latency is sort of very consistent. Right, because as you know, we turned on deduplication compression. You can compare this slide with previous slide. You can see we got some performance degradation, right? Here is 82 and we turn into 70. So because, as deduplication enabled, we will have, some write amplification as well as some read amplification. So basically it's introducing more performance overhead in terms of that. Make sense? Okay, so here we talk about how we scale the Oracle database VM. So basically when we have more database VM configured, for example, we have one VM with R1 configured, another VM has R15 configured. So we can see, okay, with two VMs configured, the aggregate IOPS we can get, 169,000 IOPS. So with more VM configured within a vSAN cluster, we can get more benefits. So it's like, so this is how we evaluate vSAN performance. We're not evaluating only one single VM, single disk. Basically, we can see, okay, with more VM deployed, we can see more performance benefits introduced by using that. Okay, so here's a new feature I'm going to introduce from 6.7. We introduced adaptive resync. What is adaptive resync? So basically when there is something happen, when, for example, you're changing the policy to a VM decay on the fly, right? From R1 to R5, basically you enable user coding so we can just rebuild all objects to redistribute the objects from 2 disks to 4 disks, right? So in terms of that, vSAN needs to rebuild the object and resync the object in the backend. So when you see there is a VM traffic starting from the beginning, and the green line means the resync traffic. So the resync traffic will stay like 20% of the data of the VM data traffic to make sure there's bring very less or very little impact to the VM traffic. Okay, so we don't want to see with the resync basically is an impact of VM traffic a lot. In this case, we just have a really bad performance from the VM perspective. So as you can see from the resync perspective, it's starting from around 3 p.m. Okay, it's very, very conservative, very, very conservative. It's up only about 20% and we're pretty consistent. Only when you find out, okay, the VM traffic is down, there's no VM traffic, then you can see the resync traffic is going up. Okay, so when there's no VM traffic, the resync traffic basically can grow up and take the entire bandwidth. Otherwise, it just stay very conservative to, avoid, impacting the VM traffic. Okay, let me just hand this to Sudhir.
Sure.
Yep.
Yeah, so that's where you can find all of this information. It's basically here in the paper. We just released it a month ago. Let you guys take a picture. Right. So previous section, or probably 2 sections before, right? We spoke about HA, we spoke about DR, we spoke about HA in a data center, we spoke about HA across metro distances. Chen spoke about performance, right? He spoke about performance metrics, Oracle 12c on 6.7, right? And you saw all of the metrics up here. What's the key thing that we're missing here? Backup and recovery. In every Oracle DBA, the bread and butter is backup and recovery. So let's focus on that. So basically, this is a paper that we released in 2017, right? And as you can see, we had we took 2 examples, one for a single instance database, one was a 2-node Oracle rack, 24 vCPUs, 256 gig of memory. It was 7.3 OEL, again, it was 12c, ASM. The key thing to this is we decided not to use any third-party tools. We said, you know what, I'm going to use what is native to vSAN and what's native to Oracle databases. And what's native? Your hot backup, right? Your archive log backup and your vSAN snapshot and clone. So using these free out of the box native tools, not going to the market to buy third-party tools, can I do all of these? So which means, can I do my backup? Can I do my recovery? Can I clone databases? Because one of the key things that an Oracle DBA does for a living, and I'm sure there are many Oracle DBAs here in the room, is cloning. The database refreshing. Well, I need a clone of this database. I need to refresh my production database, or I need to refresh a test database from the production database so that the QA guys can test the new feature of the software, right? All of that. Database patching, right? That's another important function of an Oracle DBA. So trying to use these tools and features to see, can we do that very efficiently and effectively? So that's what we did. So we said, okay, you know what? Using the backup, so using snapshot and clone, I'm going to use an Oracle hot backup, right? And I'm going to see if I can recreate that virtual machine on another site so that I can use that for database refreshing or cloning. I can also use another mechanism that Oracle provides called the crash consistent backup. So typically what happens, 30-second primer. When you set up a database in a hot backup mode, you're basically saying, I want all my data files to be consistent, right? And then full block images are logged onto the redo log file. So what happens is your data files are consistent. When you do a media recovery, what happens? You read all of the log files, and then if you have to advance the log files, so be it, you do that, right? With crash consistent backup, that's what most of the storage vendors they do. When the Oracle database is running, they take a snapshot. And when they recreate the snapshot, or when you bring the Oracle database up on another volume, the snapshot volume, Oracle does what is called a crash recovery or an instance recovery. And it does it very effectively. It's been doing that very effectively since Oracle 6 days, right? So using any of these two mechanisms that is supported by Oracle Corporation, we said, fine, can we do that backup using the hot backup and the consistent backup? Can I do it at a VMDK level? And I'll talk about the use case as well. So basically, I have a production database, right? Or a 12c OL73, and I need to clone this virtual machine so that I need to do some kind of database refreshing. I want to run some software. I want to do database patching. Maybe that's my test or my dev. So what are the steps? The first step is put the database in hot backup mode, right? You would take a VM level snapshot, right? After taking a VM level snapshot, take the database out of the hot backup mode. You would clone a new VM from this snapshot. Once you clone, go ahead and delete the snapshot, right? So what you have right now is a cloned virtual machine, which is exactly the same as the production database, excepting it is still in a hot backup mode. So when you bring up the virtual machine, the database will not come up because you need to perform media recovery. So that's what is here. You will perform media recovery, and once you perform media recovery, either you can cancel or say, you know what, I still want to advance it by supplying archive log files until time, until cancel, until SCN, or whatever you want to do, right? So in essence, I want to either clone. So my goal was to clone this database for either database refreshing, for patching, for testing a new software, or whatever, right? And I was able to do that very effectively using just vSAN snapshot clone hot backup mechanism. So there's no third-party tool involved here. My second use case is this, right? And this is typically some of the use cases that's there probably in your shop as well, right? You have multiple QA databases. You have multiple QA instances on a virtual machine. Typically, nobody usually does like one-to-one. So they'll have probably 3 or 4 QA databases on a virtual machine. The virtual machine will be a big virtual machine, right? And my use case is I just want to refresh one database here, not the entire set, just one database here. Can I do that from this production database? And the answer is yes. So the first couple of steps are still the same. You will still put the database on hot backup mode, right? But here, you would take here you would take a VM level snapshot. You would end the hot backup mode, but rather than cloning an entire virtual machine from the snapshot, you would just clone only the database VMDKs. You would only clone just the database VMDKs using VMKFS tools, right? So once you run the VMKFS tools, you just clone the VMDKs for the database. Of course, go ahead and delete the snapshot, come back here, up here, drop QA1 database. All you have to do is attach these VMDKs to this virtual machine, the target virtual machine. Once you scan your operating system, if you do an every disk -LU, you will see that. If you do an Oracle ASM less disk, you'll see it. If you want to do a scan disk, so by it, you can do that as well. Once you mount the disk on this particular virtual machine, database comes up, you have to bring it up because you still have to perform your media recovery. And again, if you wish to roll it forward, using archive log files, you can do that. So I was able to successfully refresh just one database on this target VM using the snapshot of a virtual machine, the source virtual machine, and using VMKFS tools to clone just the database VMDKs. So this is just one use case here. So basically the paper that I would show in the next slide covers all the use cases. So there are like many use cases here. For sake of time, I didn't cover it. Database patching, there's database refreshing, there's cloning. I spoke about backup and recovery already. And that's the paper. All right. So all along we were speaking about on-prem, right? It's vSAN on-prem. We spoke about rack, HA, DR. We spoke about performance. We spoke about BC. We spoke about RMAN databases, snapshot clone, and now is the time to move to the cloud, right? And some of the use cases for the cloud could be bursting. I need to burst to the cloud. I need extra seats, or I need to put my DR in the cloud, right? Or I have to expand my on-prem data center to the cloud for various reasons. And there are many sessions that speak we had, right? That focuses on VMware Cloud and AWS. We will not be focusing, but one essence I want to point out here is if you open this package, this VMware Cloud and AWS package, and look underneath, it's vSAN. So if you have vSAN on-prem, it becomes very seamless for you guys to move your workload from on-prem vSAN to the cloud and back if you have layer 2 VPN, right? So if you have layer 2 VPN between your on-prem and cloud, reason why do you need a layer 2 VPN? So that you can avoid application refactoring. You don't have to change host name. You don't have to change IP addresses. You don't have to do anything, right? Think of it. An Oracle database, single instance or rack, if you change the host name, what happens? Bad things happen to you. It will not come up. You have to go and do a grid reconfiguration. So that you're able to avoid. You're able to avoid a lot of downtime by using the L2 VPN. So once you go to the GUI, you look at your data center, you would see data source, sorry. You would see the VMware Cloud on AWS uses vSAN storage, and it basically provides two logical data stores, right? It provides a vSAN data store and a workload data store. The vSAN data store, the workload data store is for the compute, right? And then I already spoke about the seamless migration from on-prem vSAN to the VMware Cloud on AWS, which uses vSAN storage. So that's a paper that I published a month ago, and that basically talks about how you are able to migrate single instance database from on-prem to the cloud, how you are able to migrate an Oracle RAC database from on-prem to the cloud and back, right? How you are able to use, so there's a new feature on VMware Cloud on AWS called stretch cluster for VMware Cloud on AWS, right? It's stretch cluster. So basically, your VMware Cloud on AWS was within an AZ, was within an availability zone or a data center. Now you have the ability to stretch this cluster across multiple AZs or multiple data centers, right? So what's the use case for Oracle? Extended Oracle RAC. So now I have site level HA, I have infrastructure level HA. By using Oracle RAC, I have application level HA. So I have 3 levels of HA: site, infrastructure, app level. All right. Now, I'm a lazy DB and I don't want to do my work, right? So I want to automate it. I want to make my life easy so I can have fun. Let's see how we can bring it together. So basically, this is what database as a service is. The question here is, can we automate it? Do we have tools? Do we have native tools within the VMware arsenal that will help us automate it? See, technical reasons for for the database as a service, why you want to automate it. Single instance databases, I don't know how many of you guys have successfully been able to automate deployment, configuring of single instance databases. Oracle RAC, yeah, that's a pain. That's a real royal pain. Right? Especially think of it, you provision Oracle RAC virtual machines, you set up the scan, you set up the listeners, then you set up all the IP addresses, the public, the private, the VIP, the scan, so on and so forth, and then it's very complicated, right? That's why you'll see a lot of DBAs, a lot of VMware admins will kind of shy away. They'll say, Oracle RAC, oh, that's a different beast altogether. You know what? I don't want to automate it. Maybe I need the Oracle DBA to go about doing it. It takes a day and a half to actually do it, right? Single instance databases, it's easy, right? You have a template, boom, 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 you're done. So this is a solution that we are working on. Hopefully, I should be able to release it by quarter Q1 of 2019. And that has all these use cases here. So you will be able to provision. Currently, it's working. I just have to fine-tune it a bit more. You'll be able to provision a 2-node Oracle RAC, fully functional, right? All of the scripts are completely customizable. Everything is customizable. That goes back to the conversation we had day before yesterday. Yep. About automation, yes. So it's fully configured. So any custom scripts that you guys have, you can put it in the workflow, and that is using our vRealize suite. So using vRealize automation and vRealize orchestrator. Mid-touch, how are we doing for time? Good? All right. Some of the best practices for running Oracle databases on vSAN, and if you look at it, right, it's not particular to vSAN. Some of them are common, for even running it on classic ESXi or VxRack, VxRail, VMware Cloud on AWS. Chen touched a couple of those. So basically, PV-SCSI controllers for VMDKs. The reason is QTAP tuning. Keep in mind, when you have a physical architecture, right, you have your HBAs and you have your LUNs, right? What would happen is you would have to do HBA QTAP tuning. You have to do LUN QTAP tuning. Similarly, in the VMware land, you have to tune the HBA QDEP, which is a PV-SCSI controller, and your VMDK QDEP as well, so that you're able to widen the lanes on the freeway, so you're able to push a lot of IOPS, right? Typically, when I go to a customer site, I see the guy using only one PV-SCSI controller. My first question is why? Why are you so stingy? Use all 4. All 4 were given for a reason, right? That way, you're able to spread your Oracle workload, be that single instance, be that rack across all 4 PV-SCSI controllers, right? The other thing I say is NOOP, and NOOP stands for no operation. Typically, Red Hat, SUSE, OEL, if you look at it, there are 4 IO schedulers. You have anticipatory, which is dead. Then you have deadline. And then you have CFQ, which is completely fair queuing. And then you have NOOP. What do we recommend? NOOP. The reason is ESXi has its own IO scheduler. You don't want to run an IO scheduler, which is the guest IO scheduler, run against the ESXi IO scheduler. So you basically want the guest IO scheduler to shut the mind off and say, you know what? Make it a FIFO queue. Any IOs that come down the pipe, send it down, ESXi is going to take care of it. That's what NOOP is. And of course, ASM. What's our recommendation? What's VMware recommendation for using Oracle devices? ASM. Can I use CFS? Absolutely. Can I use ext3, ext4, XFS, ZFS? Sure. Right? But ASM is the recommended way by Oracle, and that's what we say. So if you ask me, okay, what are some of the best practices that you recommend? I will just point it to the Oracle documentation and say, we agree with whatever Oracle says. But that's the Oracle DBA best practices guide.
All right, I'm going to talk about the vSAN best practice from deploying the Oracle perspective. So first of all, let's just talk about how we should design the vSAN cluster, okay? So similarly, let's talk about the vSAN because we're gonna hook a bunch of the ESXi together. So I would recommend to have identical ESXi configuration. For example, identical CPU, identical memory, identical disk group configuration, because keep in mind, your performance, the cluster performance is determined by the lowest performed host in your cluster. So even, for example, you have 6-node cluster today, and tomorrow you want to scale out to, like, let's say 8 nodes or 10 nodes, right? You may not be able to find the same host to buy, you may not be able to find the same drive to buy to scale out your cluster. However, we still recommend you to buy the similar performance or better performance host or drives to scale out your cluster. So when you're at the beginning, when you're designing the cluster, you will think about, okay, what's my host should be, what's my drive should be. You think of the day 2 operation as well. So this is from the growth perspective, and from availability perspective. So we always recommend to have the spare host or spare drives. Do not just over provision your database in your vSAN cluster. In this case, we just have enough slack space for vSAN to do resync, rebuild objects, and even for for example, you want to turn on deduplication, vSAN is going to do resync for all the objects. So if we have enough slack space, in this case, vSAN gonna do it faster and more efficient. Okay, so keep in mind, design for growth and design for availability. So just keep, just basically 2 points. Keep it identical, and secondly, just keep it, give more slack space. Okay. SPBM. So SPBM can give you, like I said, capability of balance the performance or capacity, for different purpose, and we can still leverage the QoS. For example, you have high performance database running in your cluster, and you may have other VM mixed with your Oracle VM in the same cluster. So you may want to use QoS to control the I/O for each particular VMDK, to limit the I/O in this particular VMDK. You don't want noise neighbor issue happen in your cluster, right? And the second one, for latency sensitive application, you can definitely use R1 configure. Just we showed that before on the left hand side, remember? So we have all the disks configured with RAID 1, not erasure coding enabled. If you want, more capacity on your data and it's not quite latency sensitive, you can think of, okay, configure erasure coding or RAID 5 on data disk, operating system, or the FRA disks, and just keep your redo log on RAID 1. Okay. Third, deduplication compression. It provides space efficiency as well, and of course, it's going to introduce some performance overhead. And you guys can already see the graphs. I just compare with and without deduplication compression in the vSAN cluster, and what it can bring to the Hadoop slob workload. Okay. Some collaterals we can use. So basically we have a one-stop shop, which is written by Sudhir, I believe. He can give you guys the cards. You can just scan the QR code to get this directly, or if you want, you can take a picture, but it's really painful to just type the URL.
These are magical cards.
Okay.
They do a lot of magic. Trust me, they are magical cards. Come get them.
Yeah, you come to get the cards, and you don't have to just type those URL by yourself. It's painful. Yes, the references. Basically, we put all the reference architectures on vSAN on Storage Hub. So if you go to Google, you search Storage Hub vSAN, and you should be able to find out a bunch of reference architectures, not only about Oracle on vSAN. We also have SQL Server on vSAN, SAP HANA on vSAN, Hadoop on vSAN, and DataStax, Cassandra on vSAN. Okay, here's some conclusion. So first of all, you want to see cost-effective, high performance. Okay, this is what vSAN can bring to Oracle. If you guys already run Oracle on vSphere, think of you can migrate Oracle to vSAN. You can start contact the TAM to get some POC down, see what's the benefit the vSAN can bring to you. Okay, you can see how easy to create the vSAN data store to get your Oracle running on top of it. And very important thing, the key point for vSAN is SPPM, right? Because we apply policy at the VMDK level. So basically you can have the different policy created on different VMDK created. You do not have to create a multiple volume, just move your VMDK around to mess up your world, okay? And vSAN has the capability to give you the balance between performance and the capacity. So those are benefits vSAN can bring to you using SPPM. And also, with vSAN stretch cluster configure, you can just have, active, just like Sudhir mentioned before, and even with Oracle RAC configure using that architecture, and vSAN just can give you, multiple benefits in terms of that. And most importantly, I think vSAN has, as HCI, we have the most vendors in the world. Okay, we're working with a lot of hardware vendors. We have VxRail as appliance. We have thousands of ready nodes you can choose. I guess this is Sudhir's bio. You're gonna introduce yourself again?
You guys already know me, so.
Okay, so this handsome man is, he's my coworker. I'm actually representing him. So, by the way, I'm going to introduce myself as well. So, how many of you have run performance testing before on vSAN? No? Nobody? You? Okay. You know HCI bench? HCI bench?
HCI bench.
Yeah. So if you guys want to run some performance testing against vSAN, just let me know, because I'm a pro of it. I wrote a tool called HCI bench, basically just run performance testing against each vSAN cluster. I can give you the best practice, the guidance, how you should run performance testing against vSAN, how we should evaluate the performance on vSAN. Not only from application perspective, also from the synthetic testing perspective. Like for different workload, I will give you different recommendations. Okay, thank you guys.
So just one slide, VMworld, a lot of advantages for you guys being members of VMworld. It's free for you guys. The thing is, we also have a couple of SIGs. So Oracle Open World and even IOUG, we have a SIG called VMSIG, right? It's a special interest group where the only thing we do is we speak Oracle. That's all I do. I only speak Oracle. So any Oracle on VMware, that's what I do. So, consider becoming a VMworld member today. Couple of points for you guys. Please do fill out the survey. That's very critical. I spoke about the one-stop shop, right? So any other stuff on Oracle, on anything, Oracle on VMware, whether it's VxRack, VxRail, whether it's vSAN, VMware Cloud on AWS, whatever. Everything can be found there. I spoke about the magical cards here. Please come get it. The other thing is, I'm not supposed to be giving out anything in the session here today. So I have a couple of books, and I'm just going to look this side. If you guys want to grab a couple of copies, that's fine. Or else I'm just going to take it back with me. So again, for people who are listening here, I'm not giving anything out in the session. I've been told twice, right? Right? Okay, Uncle Sam is listening. Apart from that, you guys have any questions?
I have a question. If we have a vSAN and the stress cluster, then still we need a DR site, because
HA is HA and DR is DR, and never the twain shall meet. Right? Because Oracle RAC, what is it? Oracle RAC is a shared bucket, right? Garbage in, garbage out. Once you put garbage in, all the Oracle RAC nodes come down. So yes, the answer to your question is you provided HA either across sites. Still, even if you have HA on Oracle RAC across two sides, right? I introduce garbage here. What happens? Garbage flows across the wire to the other side. The other side comes down. So Oracle RAC is HA. Unfortunately, many people have this misconception. Oh, I have a straight Oracle RAC across metro distance, and hence I have DR. No, you don't have DR. You only have HA, period. That's it, no argument. If you want DR, it's vSphere replication or it's Oracle Data Guard or any other replication methodologies. But RAC is high availability. RAC is designed to fail. That's what Oracle RAC is designed to fail. It wants to make sure that you guys have high availability. So anytime you go back, talk to your Oracle DBAs. Your Oracle DBAs, definitely they know that RAC is HA. So when you design a system, make sure that you have HA and DR both set together. Right?
In terms of vSAN, almost same question. In terms of vSAN, do you consider vSAN as a single point of failure in general?
Not necessarily.
Stretch cluster, I mean.
With stretch cluster, you can have a side fader as well. So, for example, each side.
Repeat the question, please.
Oh, so you're saying a single point fader, right? So vSAN is not only designed for a single point fader. Like I say, we have a policy called FTT, fault tolerance. So basically, if you have FTT equals 1, meaning we can tolerate 1 host fader. If you have enough hosts, we can configure FTT equals 2, meaning each VMDK will have 3 copies, right? In this case, we can tolerate up to 2 host fader. And if you have stretch cluster configured, for example, we can tolerate side fader. So for example, we have 4 hosts here, 4 hosts here, and we can have the entire site down without impacting your data.
From hardware perspective, it's clear. So copy the disks, you have different servers, but in terms of the kind of software that manages this entire vSAN, is it considered as a single point of failure?
No, it's distributed. It's distributed.
Everything is distributed. The rack is distributed, the vSAN components,
yeah,
the objects,
vSAN itself is distributed.
Everything is distributed. There is no single point of failure.
Yeah.
Oracle database, this, when we have a deduplication and completion enabled, we should have like disk type, should thick or thin.
Should you have thick or thin?
Thin.
So here's the thing, right? You don't always need to have thick, right? You don't always need to have thick. The only use case I can think for thick is if your database is so I/O intensive, right? Not latency sensitive, so I/O intensive that you can't tolerate any performance issue, that then I would say is Ego Zero thick, right? Or Oracle RAC, which is, you have to set it up Ego Zero thick if you want multi-rate of flag. Apart from that, then it's good enough, right?
In your practice, what you did, like it's thick or?
It depends.
Yeah.
I'll give you a classic consultant answer. It depends. It depends upon your setup, right? Look at an Oracle database. It's always fat, big and wide, always over-provisioned. Why? How much do you need? I need 2 terabyte. Well, I should probably go and ask my storage administrator for 2 times the size of the database because my data might grow, right? So always databases are big, fat, and wide. And ugly. Some of them are ugly too, right? So what do you need to do? Thin. So I would say, general rule of thumb, dev and test, please, no thick, thin. Production database, it depends. Right? If you know, see, everything goes back to your workload profile. Everything goes back to workload. Everything goes back to your AWR, your SAR, and your workload profile, right? So there is no real answer for this. So it is by case basis. Any other questions? Any jokes, anything, whatever. I don't think. I'm at this point of time, I'm ready to just give up and go home. So anything. Good?
Yep.
All right.
Thank you.
Thanks for coming.